it says the graph shows the volume of the air in a balloon as you blow it up until it pops. What are the variables? So the variables are time and volume. Those are the variables. And you could write a narrative to describe what's happening here. If you'd like to write a sentence, you could. Or you could use the picture and just draw arrows here. So let's talk a little bit about some of the features of this graph. What's happening right here, 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 and there? What's happening along those increasing lines? Yeah.
The ones that are just going up?
Yep.
They're blowing into the balloon.
Yep. So we just say blowing air into balloon. That's right. What's happening at these level ones here? You guys know where Jacob is? We'll look it up.
Back there.
You think so? I think you might be there.
Over there.
Okay, just a minute here. Let me look. All right. So we've got those level spots. What's happening at the level spots?
They're taking a breath.
Yeah,
So
taking a breath. So you'll be doing the same thing. This is where it's nice to have the handout. You can just use arrows like high end and point and not have to redraw it. In the textbook, you might want to just write a sentence just saying, as on those increasing lines, he's blowing air into the balloon. When it levels out, it'll be just a big run-on sentence. He's taking a breath. And then right here, we have a key feature right here. What's happening here? Pop. Yeah. Pops right there and is immediately just devoid of any air. So I'm going to ask you to do that. Could you do the same thing on these next two? Maybe just study these graphs. You can describe the variables, how they're related in the context of the problem. But go ahead and explain to me what's going on each of these. All right, does anybody have an idea on the board length? What's happening here? You go to the hardware store and you ask for a board. It may come in a 16-foot length, right? A 16-foot length board. Say you only need 8 foot out of it or 4 foot out of it. What are they doing each time? They're going to sell you. Well, they'll sell you the 16-footer, but maybe you only need 8 feet. So this could be. They're cutting it down to size. Maybe cutting it to 4 foot lengths for this one. So 4, 4, 4, and then 4. And so each time take the board back, or as time passes, the length of the board is getting shorter. Or maybe you're just at home cutting it into smaller lengths. So you're making a garden, a raised bed or something for your garden. So you're cutting this 16-footer into 4-footers. So something along those lines. You need to be able to describe what's happening there. What about here? So we were talking about this the other day. It's more probably applicable with data plans. So you might have a certain amount of data you're allowed on your phone plan, right? And so included in the phone plan, you have a certain amount of data, certain amount, in this case, it's minutes of calls. When you hit your max, after that point, you have to pay per minute that you're using the calls, or per amount of data that you're using, per text or whatever, if you're using data. So. All right, matching a table and a graph. I'm going to ask you to do a little bit of this. These are called discrete graphs. Do you guys know what a discrete graph is, as opposed to continuous? Have you heard that word discrete before? Okay. Discrete just means it's dots, not connected. continuous would be connected dots. So discrete is just saying that you have specific values here that that you could have in terms of total downloads. So they're whole numbers, and there's a certain number of whole numbers. So they're just graphing on here day versus total downloads. So at the end of the day, they have a certain total of downloads. And we've got to see which one of these graphs fits this data table. Okay. We're going to be studying in this unit linear graphs. That's primarily what we focus on in Algebra 1, versus nonlinear. And there are lots of different nonlinear graphs that we'll study starting in Algebra 1 and on into the rest of your math, in Algebra 2 and pre-calculus and so forth. But let's look at this. It goes from 346 up to about 1011, right? And it goes from 1011 up to 3455, and then it jumps up to 10,426. Which of these four graphs do you think could go along with that data? Yeah. I think B. Okay. B, yep, growing. We would call this an exponential growth. It's not linear because it's not going up by the same amount each time. That would be a linear growth. Okay. This one is jumping up. It's actually tripling approximately each time. So it's an exponential growth. A is correct. We know it's not B because it's not going down. It's not C because why? What would be happening in my data table if it were C? So it can't be D because it's not going down. So D is out for that reason. It can't be C because C starts going up pretty fast, but then what does it do?
It starts to even out.
Starts to even out, which is definitely not what's happening here. And then A, A is growing like this is, but it's growing at a constant rate. So that would mean you're going from 346 to maybe it just double. Go up by 346 again, and then it'd go up by 346 again, and then again. So it just would be going up by the same amount each time. All right, so that one is exponential. That's an example of a nonlinear growth pattern. This one's actually linear here. The now you try is linear. What can you tell what it's going down by each time? So you take out dab, put your sunscreen on, you're able to just take out the same amount from the tube every time. It's a gift. Some puts that there. But take out the same amount. Can you tell what they're taking out here and which graph would go with this? So you think it's C. So we're taking out 0.2 ounces each time. Why is it not A? How can you rule out A? It goes to 0, yeah, and it shouldn't. So it is answer choice C here. It's definitely linear. It's definitely going down. So you can rule out B because B is not linear. It's not going down in a constant rate. And it can't be A because A would go all the way down to 0. So there'll be some matching. You're going to take a table and try to match it up with a graph. Okay, there's a few of those on your classwork. Sketching a graph, it says a model rocket rises quickly and then slows to a stop as its fuel burns out. So we have time down here. Go ahead and label this time. Maybe in seconds. And then we have height over here. We'll just say it's a model rocket, and we're talking about height in feet. So the rocket rises quickly, and then so it might be some kind of a model rocket. The fuel's burning, it's rising quickly. Starts down here at 0 feet, rises quickly, it's accelerating, and then it starts to kind of slow down a little bit here, at least in its climb. So what's happening right here? What do you think just happened? It's losing fuel. The fuel maybe burned out. So it's still going upward, right? But it's slowing down. Gravity's working on it. And then here, so fuel burns out here. And then it was going up, but then it starts to level out, and then it starts to drop, and it's going to drop pretty quickly. So it's dropping here, and then all of a sudden something else, a key feature, happens right here. So right here, the parachute pops out. And then from that point on, it's going down at a fairly steady rate and fairly slowly. Okay, so something like that, it's a possibility. Okay, the answers will vary on these, but you're going to be asked to draw some graphs, like in this one right here. See if you can draw the graph for the swing here. So picture you're starting, maybe you have time here. This would be height above ground here, maybe in feet. And you're starting at a certain spot here above the ground. The swing's not on the ground, it's above the ground. See if you can draw what's happening as you're pumping and the swing's getting higher and higher. And then you're going to stop pumping and the swing's going to start slowly coming down. See if you can draw a sketch of what that would look like. So as you start out, maybe somebody gives you a push, right? You start out, you kind of go up a little bit and then back down to where you are. And then if you count, the backwards motion is just going up above. It's just another up above. And maybe you pumped a little bit so you get a little higher, and then you go a little higher. And then you stop pumping, and then you start coming back down. And eventually come to a rest at the same height that you started at, but something like that. Okay. Something like that. So 3 things you have to do. You have to do describe what's happening on a graph, relating the 2 variables, matching a graph to a table, and then drawing a graph given a scenario.